Hi, welcome to another Quick Flicks episode brought to you by Summit Racing. My name's Norm. Hey, today we're going to continue with our look at the Holley Performance 4 barrels, the 4150 and 4160 series carburetors specifically, and today we're going to talk about the secondaries. Okay, so let's take a look. All right, so the secondary side of our Holley Performance 4 barrels, our 4150, 4160 carburetors, are very similar to the primary side. Okay, but before I go there, let's do this, all right? Let's think about carburetors, all right? I want to try and pull you into an area to think about, all right? So let's go back many, many years, okay? Maybe back to the advent of straight sixes and straight eights. Cubic inches are starting to come up in displacement. The demand to move beyond a single one-barrel carburetor has demanded that they take two single one-barrel carburetors and put them together and make a two-barrel, okay? Displacement requires additional air-fuel metering, and it took a two-barrel to make that happen with any type of efficiency, okay? So two barrels. If we come forward in time a little bit, now the same thing has happened again. Maybe we're into the mid-50s, late 50s, early 60s. The big three are really getting on board with some muscle car wars or some power wars, horsepower wars, and the advent to move from a two-barrel into a four-barrel comes along, okay? So the modern four-barrel emerges from the industry. And basically, just like going from a one barrel to a two barrel, taking two one barrels and putting them side by side, the same thing happens with two barrels, okay, going to four. And here's a really good example, okay, this is a HP series 4150, but hopefully you can see here, all right, the way that you're just going to look at this, hopefully, here's a two barrel carburetor, okay. If I cover the other half, lo and behold, there's another two-barrel carburetor. Okay, so let's take a look here, all right? And as I said, our 4150 HP here that we have, I've got my fuel inlet circuit, I've got mixture screws, so I have an idle circuit also. On my metering block, I know that I have jets, so I have a main circuit. Chances are extremely high there's a power valve in here, so I have a power circuit. If I lift it up just a hair, you can see the accelerator pump housing. I have an accelerator pump circuit. Now, watch this, all right? So here, let's take a look. Same thing, lo and behold, I have a, do I have it? Yep, there it is. I have a fuel inlet circuit, so needle seat, float, hinge, you know, all of that in my bowl. I have an idle circuit again. I have a metering block, so I have jets again. There may even be a secondary power valve on this side of this particular carburetor. Also, mechanical secondary, most Holleys, it is a double pumper, so I also have an accelerator pump housing and an accelerator pump circuit. Okay, so hopefully you see the symmetry, okay, the similarity of primary to secondary, and which really does lend itself to tuning. If you can get through the primary side of a Holley, chances are very good you'll get through the secondary side. Okay, I think that's where I'm going to stop on this puppy for right now. Let me just come back to vacuum secondary in a general sense, okay? Vacuum secondary carburetors, as I said, they tend to be more forgiving, okay? Hence, they only make them in certain sizes. And the reason being is they can cover more RPM in a certain range of displacement, and they cover more displacements within that range of RPM. And I know if that sounds like double talk, really it isn't. It's just that they're a very forgiving carburetor because of the vacuum controlled secondary. The mechanical secondary says, hey, you know what, Norm, give it to me. I'm putting my foot into it. All four venturis are open. The vacuum secondary says, hey, Norm, give it to me. Well, my primaries are wide open, but I'm not going to get any more on the secondary side than what the motor says give, okay? So let's take a look in detail. All right, so let's just discuss mechanical secondary carburetors for a moment here in detail, okay? The first thing I'd like to cover is application. A 4150 series Holley, a double pumper Holley, is generally going to be for competition or a very aggressive street car or truck, could be either. Generally, it's not going to be an automatic, okay? You would want to try and keep a double pumper on a manual transmission application. So, you know, an old school 3-speed, a 4-speed, 5-speed, 6-speed, whatever the case may be there, but manual transmission would be the primary application for this type of carburetor. Also, along that lines of competition, you're probably talking about a motor that has a more aggressive cam profile, possibly some gearing in the back, things of that nature that make the application more horsepower inclined, quicker or snappier through the ET, for an ET or through the traps, okay? From there, Holley does 4150s in 50 CFM increments. And the reason they do that is to help you dial in the CFM specifically for your application. Because they're not as forgiving on the secondary side, or they're not nearly as forgiving a carburetor in general as a vacuum controlled secondary, okay? So that's why they make the 50 CFM increments, you know, 600, 650, 750, you know, 859, 950, all the way up to the larger numbers, okay? So thinking about our Holley mechanical secondary carburetor then, okay? So hopefully you can see some of what I'm going to show you here. All right, so my primary side, my throttle linkage, hopefully you can see this. All right, now the way that Holleys are controlled on the secondary side is as such. All right, hopefully you can see this. I'm going to give you just a little bit of angle so you can watch the throttle plates. Okay, so as my foot says, hey, give me some throttle position, I tip in my primaries. Okay, hopefully you can see this. Somewhere around 40 to 45 degrees on my primaries is where I will start to actuate my secondary. Now this has a progressive linkage. There are some carburetors that are 1-to-1. So a 1-to-1 would be wherever my primary throttle plate was, my secondary throttle plate would also be in that same tip in or that same angle. But this is a progressive throttle linkage here between the primary and secondary. So at around 40 degrees, and that sure looks about 45 degrees. If I go a little bit farther, I can really tell that I'm half a 90 and at 45, but I've already started to open my secondary throttle plate. So let's see here. Here I'm at 40, and 45, they just start to open. Now, because it's progressive, I have to have a link that allows the secondaries to catch up and reach wide open throttle at the same time my primaries do. So the primaries open on a faster rate from this point, and lo and behold, as I reach wide open throttle, all 4 throttle plates are perpendicular 90 degrees to my throttle body here, my base plate, okay? So this is a progressive style, and as you can see, it's all off of the linkage. So whatever your foot says to do, this carburetor is going to do. Now, for competition or manual trans or something with a gear, that's all well and good, and this is the carburetor that you're probably going to want, okay? But because it does tip in at its own progressive rate, and it is mechanically controlled, it may not be the carburetor that you want for your automatic or your driver or your more moderate performance car, performance ride, okay? All right, so 50 CFMs, you got to dial them in correctly. The same thing goes with dialing on the secondary side as you would the primary side. You know, you're going to have your jets, you're going to have, chances are you're going to have a power valve. You're going to use the same methodology. And with the secondary side, keep in mind, if you can get to the track, dial in for mile per hour, okay? As long as you're going faster, you're headed in the right direction. If you get so big that you start seeing gray or black smoke come out the back and it's not oil and you haven't hurt something and you know it's fuel, then you've reached the point to where you probably want to pull back on the jet size in the secondary. Don't go any larger, but maybe pull back just 1 or 2 sizes. Also, if you get out to the point to where you've increased on your mile per hour and you see the mile per hour start to pull off or flatten out, stop going up in the jet size on your secondary at that point also. Dial in your secondary power valve by watching how you dialed in the primary side, okay? If you want a fuel hit to come on very closely to the second or the primary side, dial your power valve on the secondary side in with basically the same rating, maybe a 1/2 inch of mercury lower or 1 inch mercury lower. If you want to have a smoother transition, maybe you do drive it on the street, I would keep the power valve rating maybe 1 or 2 sizes different between the primary and secondary. Let's see here. I think we're going to take a look at the vacuum secondary side of things, okay? Vacuum secondary carburetors, they tend to be more forgiving, okay? So Holley for years only made like 2 sizes, a 600 and a 750. Because they were so forgiving, those 2 carburetors could encompass most of the displacements, most of the RPM ranges that those carburetors might be used on, okay, or utilized for. All right, so now here I have a more current Street Avenger series. Now they're starting to come out with some different sizes in the vacuum secondary platform. The Street Avenger series is very interesting because it does control the secondary with a vacuum secondary, but it does offer metering blocks so that you have the potential to go 4-corner jet, and you have the option here on this one, I believe, let's see here, yes, this is a vacuum pot with the adjustable or the quick change housing. Okay, so let's take a look at that, and hopefully you'll see what's going on with this. All right, so I'm going to use my old standby, my old reliable Race 4160 here. This is actually an older Avenger. It's my old reliable. Many of you have seen this carburetor before, and I want to show you the diaphragm in here, okay, and this will help you understand how this is all comes about as a vacuum controlled secondary. Okay, so now this is a quick change kit. It is available separately, but it does come on Avenger series carburetors. Okay, so I'm just going to take my spring out, my yellow code spring, for a moment. Now I showed you the throttle plate side of things with that mechanical secondary. I want to try and do the same thing here for you with a vacuum secondary so you can see the difference. Let me flip this. All right, there we go. All right, so we're just going to rest right there for a moment. All right, so I'm putting it on. I've got my foot in. Boy, all I got is 2 barrels. What's going on here? Well, the motor at this point would say, hey, Norm, my signal's not strong enough to pull over from a little transfer tube. It's not a transfer tube. There's a little vacuum tube or siphon tube. It almost acts like a siphon tube. If we remember the Venturi thing, right? Air and fuel are passing down these 2 barrels. Inside is a little tube, and as that air goes whipping by there, it causes vacuum. It creates a vacuum on that tube. That tube feeds back to my vacuum secondary through internal metering or internal channels, and that pulls against the little rubber diaphragm in here. Okay, now the diaphragm resistance is set up with my vacuum secondary springs. The springs have different ratings. Hey, I can tune this thing, right? Okay, but now let's say here, all right, so motor's saying I'm getting good signal. I'm pulling that, I'm whisking by on the primary side. I'm creating the vacuum necessary to pull over to the secondary. I pop a little check valve off its seat because I have enough vacuum now so that the circuit is open to the underside of my diaphragm on my secondary housing here. Okay, so I'm just going to pretend like I'm the vacuum source, and some people would argue with that. But anyhow, if I apply just a hair of pressure on the other side, so I'm pretending to be vacuum, lo and behold, my secondaries pop right open. Okay, so now they should close also off of the link with my primaries, but they don't open off of the link with my primaries. So that all comes back to vacuum, okay? And that all comes through that metering, as I said, through the crossover tube, through the vacuum tube from the primaries to the secondaries, through internal passageways over to my secondary diaphragm assembly here. Now, as we move back inside the diaphragm, okay, as I've got primary throttle position, I'm at wide open throttle. Don't lose my O-ring. Okay, now, at that point, vacuum is free to operate or actuate against the diaphragm. And I don't know if you can see this, but we're going to try it, okay? Now, my diaphragm is down now, okay? So my secondary throttle plates are closed. As the diaphragm comes up, hopefully you can see that transition, that little seal or almost like a flat piston in there, that pancake move up and down as the diaphragm goes, okay? From there, that's the primary point of this vacuum secondary controlled carburetor, okay, is that the vacuum from the engine says give, it reaches a certain point, that it lifts the check valve, it opens up the circuit. If it's enough vacuum that it overcomes the resistance of my spring, and Holley makes an assortment of springs with different ratings, then that vacuum overcomes the spring resistance. It lifts my throttle lever position. Now you have to have the throttle open on the primaries for this to happen, and then my arm was allowed to come up against the spring, and my secondaries, lo and behold, are wide open. Okay, so applications on this one. Applications for 4160 style vacuum secondary carburetors, probably going to consider automatics, okay? Almost the opposite of what we talked about with the mechanical secondary carburetors. Automatic friendly, because you can get a softer hit on the vacuum secondary. It's more forgiving. You don't get more fuel. Think about this, the fuel thing, okay, for just a moment. This is really kind of cool. We know, talking about the Venturi thing in the past and flow, we know that as I open the throttle plates, I go from a momentary point of low velocity to high velocity, and then as I open my secondaries, I get that same type of effect, okay? And thinking back to what we discussed before, when I get that opening of the throttle plate, I get that shear, and my emulsion thing may stop momentarily for just maybe microseconds, but that can be enough to create a soft spot, okay? That soft spot or that sag in performance or fuel delivery is overcome by the secondary accelerator pump circuit, just like the primary accelerator pump circuit overcomes in other situations for initial throttle, okay? But when the secondary hits on a mechanical secondary, the accelerator pump circuit on the secondary side overcomes that very same type of sag or momentary lag of fuel getting to the valve. Hence, it dumps a bunch of fuel. The vacuum secondary carburetor doesn't have that provision. That's incorporated by pulling metering over, additional metering, and by allowing the motor to dictate via the signal that's generated off the primary side. Okay, so it kind of does the same thing, but in a different way. There is no secondary accelerator pump circuit on a 4160. Otherwise, it'd be a double pumper. Okay, so application. Sorry about that. Automatic transmissions. Some race cars respond better to vacuum secondary carburetors than to mechanical secondary carburetors. Believe it or not, depends on the application. Drivers, daily drivers, as a moderate performance level, even some aggressive performance levels. As I'm replacing an OEM 4-barrel and I just need a replacement carburetor, it's probably going to be a vacuum secondary, okay? From there, don't forget the quick change housing thing is available from Holley. The assortment there on the vacuum secondary spring kit. Just making sure I got everything. Couple more sizes are now available in the 4160s with the Avenger series. 50 CFM increments on the double pumpers. manual trans, more automatic trans, aggressive, maybe not so aggressive, forgiving, not so forgiving, more tunability, a little less tunability. If I've missed anything, hey, if I've missed anything, please leave your comments and let me know. I'll be glad to cover them in the future. Please think about a subscription. Look at some additional videos if you want, and please post your comments down below. I think I'm done with the secondary side of Holley Performance 4 barrels. Thank you.